Hello everyone. This is a data structure class. So we are studying chapter 5, trees. Among them, we have finished that what is binary tree in 5.2 sections. Today we will start how we can traverse binary tree. Okay, traverse. What is a traverse? Traverse means that visit all element. That is traverse. Visit all node or element in binary tree is called binary tree traversal. So the accent is here, traversal. Okay, so how we can visit all node in binary tree? So we can introduce this three orders. So this is a parent, and there are left children and right children. So this is a binary tree. Okay. So the order of traverse can be determined by the order of visit. So if I visit left tree first, then going left. After we finish left, we can read the value or process the value in parent, and then going to right subtrees. So this one is first, value is second, right subtree is third one. Okay, so we can represent this operation as L. L means the moving left subtree, and V means that visiting the node, visiting the parent node. Okay, and R means that moving to the right, so to the right subtree. So we can represent the order of a traversal, and among them there are three types: in-order traversal, pre-order traversal, and post-order traversals. So this in, pre, post means some location of the V values, V. So if V is located between L and R, it is called in-order traversal. If V goes first, then it is a pre-order. Okay, so the name of the traversal order can be named by the location of V. V is between, in between, then it is in order. V goes first, then it is a pre-order. And post-order means that L goes last. Okay, so this is in-order traversal and post-order traversal. Among them, the most general one is that in-order traversals. Okay, so how can we visit in a real binary tree traversals? And for example here, okay, this binary tree has, this is a root node. This is a level 1, and level 2, this is a level 1, level 2, 3, 4, 5. Yes, there are 5 levels in this binary tree. uh, Using this binary tree, we can visit all node traversal, okay, using in-order traversals. So in-order traversal means that it is L, V, R. So that means that we visit left subtree first, and then after left subtree, V is red. Value is red. And after that, right subtree will be visited. Okay, so if we start from every time, we have to start from root node. Okay, we must decide which route we must follow based on this in order traversal method LVR. If we select LVR in order traversal and we start from root node, then we must go to left arrow first, and at the this node we will go to L also first rather than V, and go to L first and go to L first. And in this node we also apply the same rules. L first, L goes, but there is nothing at the L. That means that we finished L. Okay, so now next one is V. So V is A. Read the value of the node is A. So V is finished now, going to right. But right is also null. This is null. Nothings of the right subtree. Okay, so R is also finished. That means that this node itself is finished now. Okay, so we must go back to the parent. Now I am in this node. If I am in this node, L is now finished. So L is now finished. So next one is V, means that read the value of this node. So this one. Okay. So now V is finished. Let's go to right subtrees. At this node, B is leaf node. That means that there is no children from this B node. So there is no L. L is finished now. And read the value V is B. Okay. And then going to the right, nothings. Okay, so B is now finished. So we go back to parent. So at parent, now L, V, R is finished. That means that we finished all of this node are finished. So we can go back to the parent of this one. So at the asterisk node, L is finished now, L. We must read value from this node. So that is asterisk. And then going to the right subtree. At the right subtree, C is a leaf node, so we will read C because there is no children here. And then in this way, Now we finished all of this left subtree of this asterisk. Okay, so we will, L is finished, next one is V. So asterisk read, and D, next one is D, and next one is plus. Root node is now read as a plus, and next one is E. Okay, the same result of the first method. Okay, how about VLR? So VLR is called pre-order. Pre-order. The location of a V is first in this method, so that is called pre-order. In pre-order, the starting point is root, all the same. So we will read the value of this node first, that is plus, and then going to left. At the left, we will read value first, asterisk, and then going to left, asterisk for again, and then going to left and read the values, and then going to A and read the values. So at the A, there is no L value, no R values. So this is finished. Going back. So in this, from this point of view, the viewpoint of this node is that V and L are finished now. The next one is R, going B. Yes, B. Okay, in this way, you can complete all of the traversal of pre-order method. Okay, so can you calculate what is in-order traversal order and what is a pre-order traversal order, what is a post-order traversal order if you are given one binary tree? Okay, you must understand it, how to visit all of the node in the binary tree following these three traversal method. Okay, that's important here. And next one is how we can implement the traversal order method, in order traversal method. Yes. In here, in order traversal, in here, and this is a self-referential definitions. So during this in order functions, in order itself is used. But this is for L, this is for V, this is for R. So L, V, R sequence is kept in these implementations. Okay, so this printf means that it is reading the values. Okay, so this sequence of first one, second one, and third one, this sequence is very, very important. So first one is for left child, and the third one is right child. Current one is PTR point. Okay, this is in order traversal implementations. Okay, recursive function. It is a recursive function method to define in order traversal method, or self-referential definitions, or recursive function is more correct names of the method used in order traversal implementation. Okay, This is in order traversal example. Also, I think it's the same example in the previous slide. So you can have the result of this traversal is here. And next one is pre-order. Yes, pre-order also matches the VLR. So this printf is V step, and the pre-order left child is here, and the pre-order right child is here. Okay, so it follows the same sequence VLR. So this means that this is a pre-order, because this pre means that location of these V values. So that means that V goes first. The pre means that first, ahead. Okay, so this is also, the sequence is also important in this implementation. And last implementation is a post order. Post order means that L, R, V. V goes last after L and R. It is LRV. It is called post order traversals. It's also used recursive function definitions in post order implementations. Okay, yes, it's very, very important. And there are other traversal methods other than 3 in order, pre-order, post-order. It is called iterative in order traversal, level order traversal. So there are 2 other traversal methods. Among this one, level order traversal is important. So visiting at each new level from the leftmost node to the rightmost. Okay, so that is level order traversals. Okay, and let's go to, we will skip iterative in order traversal, and we can go to level order traversals. Level order traversal implementation is here, but we can go to example directly here. Okay, level order means that this is a level 1, 2, 3, 4, 5. Okay, so we visit level, lower level first, level by level. From at the same level, we will visit leftmost node first, and then going to the rightmost node. So plus asterisk and the E, and asterisk again, the division C, A, B is the traversal orders. Okay, yes, it's the concept is very simple. So if you understand it well, then it is easy to traverse level order traversals. Okay. Okay, now we can finish 5.4 about binary tree traversal, and we can go to new sections about 5.5 threaded binary tree. Threaded binary tree. Okay, thread. Thread is a long string or line. Okay, thread means that a kind of a string or lines. So we can use some unused link field in the binary tree. That is called threaded binary tree. Okay, so if we represent binary tree in linked list, then there are so many null links. null link means that it is not used. They have no meaningful information in the null link. Okay, so it's a kind of a waste of a memory space. Okay, so we will invent new method to utilize unused null link. So make use of this unused null links. Okay, so the method is using thread. Thread means that we will make some string, some lines using null links. So we can replace the null links by pointers. Pointers. This pointer is called thread or line or string. Okay. So now the current node is a PTR. Then PTR's left thread is through. So that means that we will add extra additional field left thread. Okay, so that means that we have only 3 data left link, right link. That is a usual binary tree node. Okay, this is a ordinary binary tree node, but we will have two more additional field in the threaded binary tree. This one is called left thread. And there is one more additional field is a right thread. Okay, both of these new introduced introduced field are flag field. Flag. These two are flag field. Flag field means that it has only yes or no, true or false. True or false. Okay, so this left thread is true, then that means that the left child link field is a thread. Yes, the meaning is the same. Left thread is true, then left child is a thread. Okay, if it is not else, then left child is a point to the left child. So this meaning is original meanings of left child link field. But in this design, they will utilize null link field if we flag that left thread is true. Okay, then what is the thread meanings? So the left child thread means that it is the node before of this pointer, before of this node, before. Okay, that means that there is some sequence. That sequence is called the traversal sequence, traversal orders. So in the traversal order, what is the before node of this current node? That will be pointed by using this thread. By using this thread. Okay, and if PTR current node's pointer of right thread is true, that means that this is true. Then this field, link field, meaning is changed to a thread. This thread meaning is pointing to the node after this current node. What is the next node? This is a next node, and the before node, previous node. Okay. Else, if it is not true, then right child is a point to the right child. This is original meanings. Also original meanings. So in this design, they will change the meaning of original meanings of right child and left child. If we flag that left thread is true or right thread is true. Okay, that is a threaded binary tree. Okay, actually it is binary tree, but this threaded binary tree has additional meanings. Where is before node? Where is next node? So that is added into the ordinary binary tree. That is threaded binary tree. Okay. So that means that this threaded binary tree has 5 field, 5. Okay, as I said before, they added left thread and the right thread, 2 fields. These 2 fields are flag field. Flag field means that it is true or not, true or false. Okay, this also has true or false. The other black field is left child data and right child is all the same at the ordinary binary tree, general binary tree. Okay, so this is examples. So here A is root node, B and C are left child, right child, left child, right child. So only they are all solid line here, but at the leaf node H, the left child and the right child link fields are all null because there is no right subfield or no left subtrees. Okay, so they have all null values. Okay, so this all null values are waste of memory space. So we can utilize to pointing what is before, what is next traversal orders. So if we think H, what is before of this traversal method? Okay, in order to think what is before of some node, we must decide, we must fix what is a traversal order, traversal method. So we already know that there are 3 methods in traversal method. First one is in order and the pre-order, okay, and the post order. So if we think in order traversal, in this example, LVR. So we can go to H and read H and D and I and the B and the E, A, E, F, C, G. Yes, that is in order traversal. So I can make traversal order in my head. in my brain here. Okay, so you can practice it and you can do it also yourself. H, at the H, what is next one? Next one is D. So I want to utilize the right link field. Currently it is null, but now I can utilize it. What is next of H? And what is before of H? So before of H, it is header node. If we have a header node here, this is before because H is the first node to visit first node. So if we have a header node, this left child link field currently null value will be changed to the pointing to header node. And if I am in I, what is I before node of I? That is D. And what is next of I? B. Okay, so before we can utilize left link field, and the right child link field will point to the B now. Originally it was null. Okay, so can I ask one question? That what is left thread of node I? Can you answer it? What is left thread value of I node? Can you answer it? If you understand this design completely, then you can answer it. Okay, left thread is a flag field. That means that it is true or not. Okay, this I node has a thread here. Okay, that means that this left thread is true. Okay, in this way, I can make as many questions as possible here. So next question, this one is the first question, question 1, and question 2. What is right thread of B? B node is here. So right thread related with this right link field. So right link field is used to point the right subtrees. Okay? In order to do that, we must assign what value to right thread? It is false. Okay, because this link field is not thread. Right thread is false. It link pointing to the right subtrees. So this value should be false values. Okay, so it's very important here and the interesting design to utilize unused null link in the ordinary binary tree. That is threaded binary tree. Okay. Okay, so this design, this is a root node. Oh, no. This is a root node. No, this is a root node. And this is not root node. This is a header node. as is written here, head node of the tree. Yes. Okay, this is a artificial head node here, and this is actual tree, and A, B, D, and this value. Okay, so this value is false, and this value is true. Can you recognize it? Yes. My question, two question is that what is the value of uh, left thread in node I? It's actually true. And what is right thread value of node B? It's false. Okay. Yes. It's very, very important in threaded binary tree. Okay. Okay, so here in order traversal of a threaded binary tree, so if we have a threaded binary tree, how can it follow in order traversals? Okay, so if right thread value is true, flag field, then success, or that means that next of the current node is we must follow right child link field. And right child right that mean, else means that right thread is false, then this left child link field is real left child. Okay, so that is important in threaded binary tree. Okay, so that is implementation of in-order traversal in threaded binary tree, but we can skip this one, in-order traversal. And next important one is that how we can insert a node into threaded binary tree. Okay, so there are many cases we must design in threaded binary tree insertions. So this is one case. Insert a new node as a child of a parent node. And especially if we insert as a left child or right child. Okay, and also another case is that original child node an empty subtree or not. Okay, so there are so many cases we can think in threaded binary tree. So this is an empty case. Case 1. Inserting a node as the right child of the parent node. Okay, so there is B is a parent node. Currently there is no right children here, so I want to insert D, new node, this is a new node, as the right child of B. Then this, now this is connected. Now B's right thread becomes false from true. So this is not used. Okay, dotted line means that thread, but thread is not used at the B node if we insert new node as the right child of B. Okay, but this node, D node, has two null link because it becomes leaf node now. So this left child uh, must point to the what is before of this D. It is parent B is before of D. If we apply in order traversal method, and for this right children of D, it is the header node because this is the last one, so it will go back to the header node. Okay, so this one pointing to the header node, right children adjustment is first step, and this left child adjustment is second step, and then it is connected. Okay, so after this insertion, this one, parent B's right thread becomes false. Originally it was true, but after insertion, the value becomes false. Should be false. And the child D, left thread and the right thread value becomes true in order to indicate that right child and the left child is thread. And the child's left child pointing to the parent B. This is B. And right child is pointing to the parent's right child. Okay, this one. This one will be assigned. This one will be assigned to the this right child. Okay, and parent right child is child. Yes. So in here, D. This is number one, and this left child is parent. This is number two. In here, red number 1, 2, 3, and the 3 is last one. Okay. Okay, and these two values are very important also. All of the operation or all of the change happens during this inserting a node, as the right child of the parent node is this 5 lines. Okay, so you must understand this well in threaded binary tree. And next case is case 2. Inserting a node as the right child of the parent node, non-empty case. Okay, so B has right child D in here, but I want to insert at this point X. I want to insert a new node X. Okay, so the result is here. X is inserted as the right child of B in here. Okay, then what kind of values must be fixed. Okay, so there are 1, 2, 3, 4 values should be changed. Okay, so this one is here, and 2 is here, and 3 is here, and 4 is here. Okay, so you must understand well. First one is right child value should be assigned as parent's right child, and right thread should be parent's right thread, and left child becomes child's left child becomes parent, that is before thread. Okay, so the thread flag field must be true. And parent's right child, originally thread was false, also false after inserted. Okay, and temp child is child. Okay, that is right insertion in a threaded binary tree. Okay, that's all for today, and I will continue 5.6 next time. Thank you today. Bye.